Hi guys, and welcome back to Max Electronics. In today's video we will be making an interface to connect your projector with a motorized screen that you may have purchased from AliExpress or eBay. But before we get to this, I'd like to say a few words about PCBWay. They have a Christmas sale on, which will last till 31st of December. So let's have a look what they got. Free prototyping for Christmas designs, up to $20 discounts. Flex PCB prototype starts at $89. CNC machining from just $24.89. You can also answer some questions and get coupons from $5 to $100 depending on your order. You can order a variety of different items such as Christmas badges of different shapes and designs. And of course, there's a Christmas sale where you can get 50% off the PCB and assembly orders. You can also win a $100 coupon for sharing your Christmas project on PCBWay. Don't forget that PCB prototyping starts at just $5 for 10 pieces. There are special sales in PCBWay store and plenty of shared projects to check out. So again, you still have time to get on their website and check out the cheapest prices you've ever seen on PCBWay. Prototype the easy way with PCBWay. Quality, integrity, reliability. So here we are at the bench with circuit boards from PCBWay, who are sponsoring this video. Don't forget about the Christmas sale. There's some awesome stuff and great discounts there, like I've mentioned before. So we've got the components that we need. Let's go over the schematic. Let me zoom in for you and we'll go over, I'll explain what that is in a second. So all the files, again, available if you want to make those circuit boards, the ready files, zip file, ready for you to upload to PCBWay on the Patreon. Just copy it, download it, go to PCBWay, click upload files, and it's there. We've got here neutral in, loops in and out. I'll show you in the circuit board. Going through the transformer, which is 240 to 12 volts AC. Then we've got live in and out, fuse. There is a little fuse here, so if something goes wrong, that fuse will go. It'll stop the power completely to the unit. Live out, just as a redundant port. Generally, we don't use that live out. And then we've got screen up and screen down. So generally, if you don't know how the screens work, I've repaired it before, one of the motorized screens, and you can click on this link right here, and you'll get to that video to see how the screen works. The screen has auto stop, so if you get the cheap eBay screen or from AliExpress, they generally have the wire and the switch on it, just a 3-position up, stop or down, and once you click up, it'll go all the way up and stop because the screen has the stopper inside. And the same way, if you press down, it'll go all the way down and stop, and you can adjust the height. Again, click on that video and watch that video if you've missed it. So we've got 2 relays here, single pole, single throw, which will cut the power once the screen is up and standby. So it'll just literally just cut the power to the screen. We've got the dual pole, dual throw relay. Again, it can be a dual, single pole dual throw, but I've done dual throws just for current, for high current. We've got 2 transistors, 2N2222, that are driving those relays with, of course, back diodes. The resistors to prevent false triggering, resistors to the base of the transistors. We've got 2 optocouplers. It's double isolated board. So the first isolation from 240 is the transformer, which will isolate this, and the second isolation is the optocouplers that will isolate it from projector. So this is your trigger in 12 volts, little 104 capacitor for stability, 2 resistors for the optocouplers, and that's the first part of the circuitry. So this will be isolated. Again, very simple. 12 volts in from the projector, capacitor for filtering, and that will trigger both of them at the same time. 2 optocouplers, which is a PC018, the standard, or 118, something like that. Again, all the part lists available on Patreon. there is a little interesting, so the transformer gives us 12 volts. Again, it's fused on the output of the transformer here. It goes through a bridge rectifier. From there it goes to a smoothing capacitor and a couple of electrolytics. From there it's got a little LED just to show the power is on, and this capacitor here is the delay. So what happens is when the screen goes up, the relays, or both relays, will open up. Since there's no power here, the both relays will click and turn off, but this relay will stay on thanks to this capacitor here. And the value of the capacitor, which in my case I used 1000 microfarad, which gives me roughly 40 seconds, will keep this transistor Q2 on for 40 seconds, which means it's enough time for the screen to go up, and 40 seconds later that relay will turn off, cutting the power to the screen completely. And once you apply the power, relay will click, and yeah, off we go. So the screen will generally have 4 wires. The cheap screens, some of them may have more, but generally 99% it'll be 4 wires. One is the earth, which will be, there's no earthing on this circuit board, it's connected externally, so you'll connect earth to your wire. So that'll be the screen earth, that will be the mains earth. So that would be the neutral, screen neutral again, and that's common to, that looks like a capacitor, but anyway, that's connected to the mains neutral. And this is screen up and screen down. So generally when you buy the switch one, there is a switch there that will go to live, and that switch literally switches from screen open or screen closed, and you just toggle between those two. But we're going to be connecting those to the circuit board, and that's the output here. So now that we've went over the circuitry, let's have a look actually at the circuit boards, and then we'll assemble it and try it out, and I will show you the installed version. So there is a really good quality circuit boards here, as you can see. Again, if you want to order exactly the same circuit boards, download the file from Patreon, upload it straight to PCBWay, and there we go. So this is the interface. Here are the position for the relays, the fuse, the T1L and T1N, which is those 2 pins here. They are for the transformer. So you can easily connect the transformer externally. So I've just got this transformer that gives 12 volts live and 12 volts AC. This is for neutral right here, just one of those rising clamp connectors. I prefer the rising clamp connectors because they are very old, the side. They are really good with holding the wires. You get the blue ones with the crimp ones. I don't like them, but the rising clamp are really good. So that's neutral, and that's 2 connectors joined together just like that, and they are for the down, screen down, live in, live out, which is not used, and you can use it for an indicator or something, and screen up, the fuse, which is the T 10 amps. I'm using 6.8 amps, T for time delay, so if there's a sudden inrush of current it doesn't blow. Those 2 holes were covered. This is the F 1 amp fuse here, sorry, right here. So it's fast blow because there is no inrush current, so in 1 amp is plenty to power this. That's for 2 through-hole transistors, 2 relays, and again that's the configuration of relays. So the middle pins are common, and it's normally closed in this position and normally open in this position here. Again, this drawn as schematic. That's the capacitor. C5 is the timing capacitor, so you can change the value of it. You can put 2000 microfarad, it'll give you probably a minute and a half, but screen generally retracts in about 40 seconds, that's plenty. 2 optocouplers, that's the input for the trigger. 2 electrolytics just for power, the diode bridge here, fuse for the transformer, that's 12 volt coming back from the transformer, the AC. And on the back here we've got all the supporting, so that's 2 diodes for the relay, resistors for the transistors. The R7 is the 0 ohm link, it's just there for future use. LED with a resistor here for the power indication, smoothing capacitor here, and again smoothing here, and 2 resistors for the optocouplers. So that's it. Now let's get also, here's another thing that I wanted to explain. You can add external LEDs, which is I've done here. All you do is just grab a couple of LEDs with the wires. Where are they? Here they are. And you can just connect them directly to the relay right here at those points here to indicate which relay is on, just as an indicator. You don't have to do this. I like to see, so you can just connect them right here. Where the coil is. And another thing with that is just when I thought, okay, well, since the screen's built into the ceiling, and if I need to, clean it or do something without turning the projector on, I've done a little switch here that will manually, it's non-latching, dual pole, dual throw switch. So I can actually push it down and hold it, and the screen will open. And as soon as I let go, it'll stop. And same going opposite way, and that's without the triggering auto close. So I can just extend the screen to any position I need to and close it to any position, just for service purposes. There's only 3 wires, and how I've done it, so we've got that's the back of a switch, as you can see right here, and what I've done is join that's one side of the switch and that's the other, and you join one wire to the first and last pin, which is the positioning of the switch. Those are commons, and to the other side. So this one will trigger the first relay that activates the circuit. No matter which position, if you go up, it activates it, or if you go down, it activates it. And those just soldered to the transistors. So the common one of the main relay connected to pin 1 of Q1, which is ground, which is the output of the transistor. The 3 common pins connected to Q1 pin 3, which is just ground, and the common one of the open screen connected to Q2 pin 3. So when you flick it up, those get connected, and this get connected, and the screen opens up. When you let go of it, nothing's connected, screen's frozen, and when you go down, this one's obviously blank, and this transistor gets short-circuited, and screen goes up, and it's okay. So on the schematic, technically what we're doing is we're short-circuiting collector and emitter with a switch here, and here. All right, let's start assembling the circuit board. The board is soldered now with the transformer and little additions. Again, you don't have to have this switch or LEDs if you don't want to. This is just something extra that is not necessary. The board with the transformer is necessary. the rest is not. Again, be careful, this is a high voltage project, well, partially high voltage. This side is fully isolated, that half, but this side is at the main voltage, and if you don't know what you're doing, please don't do anything. So I think it is time now to hook up the just an indicators as indicator to see what's happening with the screen. So I'm going to go connect this to neutral, out, loosen them, and of course I'm going to connect the mains. It is unplugged at the moment, just in case you're wondering. So we got neutral and we got live in. So let's hope I've sorted everything correctly. All right, so we're going to try it manually first by, let me zoom out a bit so you can see the whole picture. We're going to try it manually first by using the switch to open and close, and then we'll add 12 volts into here just to simulate the trigger output from the projector, and we'll also time it to see how long it'll take to open and close. So right now there should not be any lights. I'm sure you'll be able to see those. Let me stand them up, maybe that'll work better. Yes, so I've got red one connected to screen down, so, and the green one to screen up. All right, so here we go. All right, I can see the LED lit up under there and nothing else. So let's try, I'm not sure which way. Okay, that's working. That's down and that's up, as you can see. So that's working just fine. And you can see the relays are clicking. If it's the red one, that's the up, energizing the board. That's why I chose red, and the green and red, which means it's energizing the board and going down. All right, now I think it's time to simulate the 12 volts and see how that works. So that would be the 12 volts. That is still live. Let's connect it. I haven't applied the 12 volts yet, so we're just going to connect it here. All right, so now the 12 volts is there, so I'm about to turn the 12 volts on now, and as you can see, the screen is going down, and as the screen reaches down, it'll stop by its internal stop system. The light is on. And now let's time and see how long it'll take to turn off once I disable the 12 volts. It should take roughly 40 seconds maybe. So we've got the stopwatch right here. And on the count of 3, 1, 2, 3. So, oh, that didn't take long. I wonder why. That was a little, maybe there's a bad capacitor. Let me check that. Let's try it again. So we've got that on and then off. It takes a couple of seconds, which it shouldn't. So I'm going to have to investigate that capacitor and maybe replace it. I think that's a bad capacitor, and I will be right back. I've replaced the cap. It was bad. So unfortunately I didn't have any smaller caps, so it's a larger size. It's still 1000 microfarad. So again, let's plug that in. And as you saw, the light came on in the background there, so it's energized, and we've got this working just fine. Okay, now let's apply 12 volts as a trigger, and here we go. So that's on, so the screen will be coming down now. And let's time it again and see how long it will take. Ready? 1, 2, 3. So it took 38 seconds for it to turn off the relay, which is fine. Sometimes screen can take 30 seconds to wind up. If it's longer, we can just update the capacitor and put a 1500 or 2000 microfarad and adjust it that way. It doesn't matter how long it will stay on. Once the screen is retracted, the screen will stop, and this will just keep the circuit energized for that amount of time. So even if you have 2 minutes, if you put 2200 microfarad capacitor and the circuit stays on for 2 minutes, it doesn't matter, as long as it at the end just switches off the whole circuitry and cuts the power to the screen. So let's now have a look. I've already got, this is a second circuit board. I've already got one made and installed in my screen in my bedroom. So let's get up on the ceiling, like in the attic, and have a look what it looks like. So here is the unit installed already on the ceiling, and let me just dim the light so you can see better. Well, that's the interface anyway. You can see the red light here. It is very hot in the attic, excuse the shaking. So I can operate it manually by simply opening the screen. You can, I don't know if you can hear it, or I can go up. Or so that's the cable that is going onto the screen itself. And on this side, well, actually it's at the bottom, I believe. It's really hard to get a good picture there. That's the main input, and that's the barrel plug for the trigger. So that's the screen. Oh my god, it is horrible up in the ceiling up here, but that's the unit. So let's have a look for the screen in action. So I'm going to turn the projector on here, and it takes, usually with this one, takes a few seconds before the screen starts retracting. My other projector is instant. As soon as you press the power button, it opens up, and as soon as you turn it off, it shuts down. But this one takes a few seconds for the projector to come on, and the screen then opens up right about now. There we go. So here we have it. It works just fine, and the image should come on any second. Here we go. So once the screen's fully open, there we go. So it is working just fine, and we'll turn it off in a second as well, and I'll show you how it shuts down. So I'm going to turn it off now, and let's watch it shut down. There we go, now it's shutting down. So that's it for this video. I hope you enjoyed it. If you have any questions, feel free to ask me in comments. I read all the comments. Don't forget to like, share, subscribe. I hope you enjoyed this video. My name is Max. I will see you next time. Bye.